We're talking about a game changer. Game changer that's going to change the landscape.
But just as we once made a dramatic shift from making looms to making automobiles.
Hello, automotive aficionados. You might believe you have the future of cars all figured out. Perhaps you're convinced that electric vehicles are the definitive solution for clean transportation. But what if I were to tell you that nearly everything you've been led to believe about the automotive future is inaccurate? I make this claim because Toyota has just dropped a bombshell that could change the entire game, while other automotive giants were showcasing their latest models on grand stages. Toyota was quietly engineering something in the background, something powerful enough to leave the auto industry in shock. In a surprisingly direct statement, Toyota's CEO captured the headlines with a proclamation few saw coming. Our new dynamic force engine will spell the end of electric cars. This wasn't a mere product announcement, it was a stark warning. It was a signal that Toyota is no longer content with playing a background role. So, what is this engine, really, and what makes Toyota so certain it will eclipse the competition? Let's delve into the true story behind Toyota's most audacious move. In years, but before we proceed, be sure to hit that subscribe button to get every new update from the automotive world delivered to you first. Now, let's explore the rise of Toyota's dynamic force engine strategy. Toyota isn't just making minor tweaks to its engines, it's fundamentally reinventing how they function to address future demands. With its new dynamic force engine family, Toyota is doubling down on enhancing internal combustion engines, even as many other companies pivot entirely to electric vehicles. These engines aren't just small improvements. They're a core component of a long-view strategy tied to Toyota's global design philosophy, known as TNGA, or Toyota New Global Architecture. This framework enables Toyota to construct vehicles that are more robust, more efficient, and simpler to manufacture. While many competitors focus exclusively on electric cars, Toyota is advancing both combustion and electric systems. The CEO of Toyota has stated that the new dynamic force engines are a massive part of the company's vision. These power plants are engineered to consume less fuel, produce fewer emissions, and yet deliver robust performance. They're also adaptable to various fuel types like ethanol or even hydrogen. Toyota maintains that internal combustion engines have significant room for improvement and will continue to play a crucial role in the future of mobility. This decision is rooted in global realities. In numerous countries, EVs are impractical due to a scarcity of charging infrastructure and unreliable electricity. In such regions, highly efficient combustion engines remain the most viable option. Toyota is developing engines that can thrive in these environments while adhering to environmental standards and maintaining affordability. The new dynamic force engines are engineered to integrate seamlessly with Toyota's TNGA platform. TNGA is a modular system that permits different models to share common components and design principles. This approach cuts down on production time and simplifies the process of using the same engine across a wide range of vehicles. For instance, the same engine block could be utilized in both a compact sedan and a larger SUV without requiring a complete redesign. This methodology allows engineers to concentrate on refining the engines rather than redesigning from scratch. For every new model, it also enables Toyota to roll out updates and enhancements to multiple models more rapidly. This strategy conserves resources, minimizes waste, and paves the way for future adaptations, such as transitioning to new fuel sources. The dynamic force engines prioritize more than just speed and power. They are engineered for efficiency, reliability, and environmental consciousness. One of the cornerstone achievements is their exceptional thermal efficiency. This metric reflects the engine's ability to convert more fuel into kinetic energy instead of losing it as waste heat. These engines also employ a longer piston stroke and a sophisticated combination of fuel injection techniques to boost performance. While cutting emissions, the cooling systems are also more sophisticated, with electric water pumps and superior temperature regulation helping the engine maintain its optimal operating temperature. This extends the engine's lifespan and ensures it performs well in diverse climates. Every component of the engine was meticulously designed to balance both performance and fuel economy. The Dynamic Force series consists of three main engine types: a 3-cylinder, a 4-cylinder, and a V6. The i3 is compact and fuel-sipping, ideal for smaller cars. The i4 is the most prevalent variant, found in a wide array of mid-size vehicles. The V6 is the most powerful, designed for larger vehicles requiring more muscle. Each engine is capable of working with multiple fuel types. Toyota is actively testing alternatives like ethanol and hydrogen. These engines are also designed for hybrid integration, allowing them to be used in both combustion-only and hybrid electric vehicles. This provides Toyota with a wide spectrum of options for new vehicle development. Toyota manufactures these engines in its global factories. The design facilitates flexible production, enabling the same engine to be built in various countries using local components. This reduces lead times and costs while ensuring high quality. It also helps Toyota navigate supply chain disruptions or shifts in regional demand. Because these engines are built on the TNGA system, Toyota can swiftly alter production to meet local requirements. For example, if a market demands more ethanol-compatible engines, Toyota can reallocate resources without massive operational changes. This level of adaptability is invaluable in today's fast-evolving auto industry. Now, let's examine how this helps Toyota compete. The Dynamic Force engines provide Toyota with a distinct advantage. While competitors pivot away from combustion engines, Toyota is perfecting them to satisfy both present and future demands. These engines are prepared for multiple energy sources and integrate flawlessly with hybrid systems. This versatility makes them highly relevant in numerous markets, particularly where EVs are not yet a practical choice. The innovative engine design combined with the TNGA system helps Toyota control costs and maintain high quality. This translates to customers receiving cars that are efficient, reliable, and ready for future technologies, all without compromising on performance. Through TNGA, Toyota can manufacture a diverse range of vehicles with fewer alterations to their production line. It also simplifies the integration of new technologies, like the Dynamic Force series, across many models without overhauling the entire vehicle. This accelerates development and trims costs, while still allowing each model to possess a distinct character and purpose. A primary objective of TNGA is to support emerging technology, which includes not only enhanced safety and comfort, but also new powertrain types. The Dynamic Force engines are designed to fit perfectly within the TNGA framework. This means engineers are not forced to redesign the car each time the engine is upgraded, helping Toyota stay competitive in markets where clean energy is rapidly expanding. By creating flexible vehicles that accommodate different power sources, Toyota can adapt its product line without major redesigns, a significant edge in today's dynamic auto industry. Several vehicles built with TNGA and Dynamic Force engines are already on the market. Models such as the Toyota Corolla, Camry, and RAV4 utilize this combination and have demonstrated marked improvements in both performance and fuel efficiency. Drivers report better gas mileage, sharper throttle response, and a smoother driving experience. For Toyota, these outcomes validate the effectiveness of the TNGA strategy. It facilitates rapid innovation, shortens production cycles, and aids in the deployment of new engine tech across numerous models, securing the company's strong footing in both established and emerging markets. Every significant advance in automotive engineering starts with the engine. For Toyota, the Dynamic Force engine signifies the next evolution in internal combustion technology. These engines are not a simple modification of older designs. They represent a fundamental reimagining of how power, efficiency, and emissions are managed. Developed from the ground up and built to integrate with Toyota's TNGA platform, the Dynamic Force family emphasizes thermal efficiency, intelligent air-fuel management, high-speed combustion, and mechanical precision. Toyota's engineers aimed to achieve what many deem nearly impossible, elevating thermal efficiency in a gasoline engine to levels previously associated only with hybrid or diesel. POWERTRAINS. In internal combustion engines, Thermal efficiency is the measure of how much of the fuel's chemical energy is successfully converted into useful work. Conventional gasoline engines typically operate with a thermal efficiency between 30% and 33%. The dynamic force engines shatter that ceiling, achieving figures of 40% in gasoline-only versions and an even more impressive 41% in hybrid applications. This leap forward is the result of a suite of technologies working in synergy. Rather than targeting just one system, Toyota examined how every facet of the combustion cycle could be optimized. This included fuel delivery methods, airflow into the cylinder, the shape of the combustion chamber, and heat management during ignition. Enhancing all these aspects culminated in the record-breaking efficiency numbers Toyota now touts. One of the most profound changes in Toyota's dynamic force engines is the piston's movement within the cylinder. These engines are constructed with a longer piston stroke relative to prior designs, which means the piston travels a greater vertical distance. This design elevates the compression ratio and enhances the engine's fuel efficiency. For instance, the 2.5-liter Toyota engine can achieve a compression ratio as high as 13:1, or even 14:1 in some variants. A higher compression ratio leads to a more complete burn of the air-fuel mixture, resulting in more power and less wasted energy. However, this comes with a risk. Higher compression can lead to engine knock and uncontrolled ignition of fuel. Toyota counters this by using advanced cooling systems, precise spark timing, and meticulous fuel delivery. It's a delicate balance of extracting more power without compromising engine health, and Toyota's engineers have mastered it through careful, incremental improvements. Fuel injection technology has seen some of the most dramatic advancements in modern engine design. Toyota's dynamic force engines utilize a cutting-edge system called TeslaVerse, which integrates both port injection and direct injection. Port injection sprays fuel into the intake manifold, whereas direct injection shoots it directly into the combustion chamber. Each method offers distinct advantages. Port injection aids in keeping the intake valves clean and performs well at lower engine speeds. Direct injection produces a finer fuel spray and enhances power, particularly under heavy load. Toyota's TeslaVerse system intelligently combines both, switching between them or using them simultaneously based on the engine's immediate needs. This dual-pronged system elevates both power and fuel efficiency. It also contributes to lower emissions by maintaining an optimal air-fuel mixture across all driving scenarios. Whether you're cruising in city traffic or accelerating onto a highway, the engine adjusts instantly for peak performance and economy. To elevate airflow and combustion to new heights, Toyota has enhanced the materials and manufacturing processes. For the engine head, a notable innovation is the use of laser-cladded valve seats. In this technique, a highly durable metal alloy is fused onto the valve seats with a laser, creating a surface that is smoother and more resistant to high temperatures. This ensures a superior seal, minimizes wear, and promotes consistent combustion. Over the engine's lifetime, Toyota also improves airflow into the engine with ultra-precise machining. The intake ports are polished to an almost mirror-like finish, which reduces air friction and optimizes the flow of air into the cylinders. Superior airflow means more oxygen is available for each combustion event, which boosts both power and efficiency without the need for a turbocharger. Variable valve timing is not a new concept, but Toyota's implementation in the dynamic force engines incorporates a clever innovation. Conventional systems use oil pressure to adjust valve timing. Toyota substitutes this with an electric motor on the intake side, a system named VVTIE. This modification enables the engine to alter valve timing with greater speed and precision, particularly during cold starts or low-load driving. This is significant because valve timing directly impacts the engine's breathing. With finer control, the engine can seamlessly transition between fuel-efficient and high-performance modes. It also enhances engine responsiveness and reduces emissions, which is especially beneficial in stop-and-go urban driving. Another key feature is Toyota's advanced cooling system. Instead of a single coolant circuit, these engines employ multiple channels that independently target specific areas like the cylinder head, engine block, and exhaust system. This intelligent design allows the engine to warm up more quickly from a cold start and then cool with greater precision once at operating temperature. A faster warm-up time reduces emissions, while precise cooling helps the engine maintain its strength and perform optimally for longer. Sensors continuously monitor temperatures and adjust coolant flow to match the driving conditions, creating a smart system that keeps the engine efficient and durable in any climate. Friction is a hidden force that silently robs an engine of its performance. Every moving component, from pistons and camshafts to valves, generates resistance that consumes energy. Toyota's engineers worked diligently to minimize this friction throughout the dynamic force engine. They applied low-friction coatings too. The piston skirts implemented roller rocker arms in the valvetrain and optimized the flow of oil through the engine to reduce drag. Even the timing chain was re-engineered for less friction and noise. While each individual change may seem minor, their collective effect is a smoother, quieter engine that consumes less fuel and has a longer operational life. Toyota engineered the dynamic force engine with stringent global emissions regulations in mind. To reduce emissions at the source, the engine employs fast-reacting oxygen sensors and high-capacity catalytic converters. The catalytic converter is also positioned nearer to the engine, allowing it to heat up faster and begin working more quickly after ignition. In hybrid versions, the engine can shut down entirely during low-demand driving, allowing the electric motor to take over. When the engine re-engages, it does so smoothly and cleanly. This is a prime example of the synergy between Toyota's TNGA platform and the dynamic force engine. The system is designed to support both gasoline-only and hybrid power, with software seamlessly managing the transition between them. While the majority of vehicles still run on gasoline, Toyota has designed these engines to be compatible with other fuel types. In some regions, ethanol is a common fuel. In others, engines must be able to run on low-sulfur or blended fuels due to local regulations. Toyota has tested these engines with ethanol and verified their compatibility with flex fuel systems. The company is even investigating hydrogen as a fuel for combustion engines. This is distinct from hydrogen fuel cells. In hydrogen combustion, the engine burns hydrogen in a similar manner to gasoline, but the primary byproduct is water vapor. The GR Corolla H2 project is one example of this exploration. While still in its early phases, it demonstrates the versatility and forward-thinking design of the dynamic force engine. The backbone of this strategy is the TNGA platform. Toyota's TNGA platform is more than just about improved aesthetics and stronger vehicle chassis. It's a strategic framework for deploying new engine technology on a global scale. Since TNGA was conceived from the outset to accommodate the dynamic force engine family, Toyota can readily mix and match various engine sizes and hybrid configurations without undertaking a complete redesign for each model. This agile system allows Toyota to use the same fundamental engine architecture worldwide while still catering to local requirements and regulations. It accelerates development, reduces production costs, and offers drivers globally a more uniform and refined experience. Whether a customer is purchasing a Camry in America, or a V4 in Europe, or a Corolla in Asia, the core engine technology remains consistent, efficient, reliable, and prepared for the future. The initial models to receive the dynamic force engines were some of Toyota's most critical global vehicles, the Camry or AV4 and Highlander. These models were also among the first to transition to the TNGA platform, making them the perfect candidates for the new power plants. In the Camry, Toyota introduced the 825AFKS, a 2.5-liter four-cylinder gasoline engine generating approximately 203 horsepower, mated to an 8-speed direct-shift automatic transmission. A hybrid variant was also available, providing 176 horsepower from the gasoline engine and a combined 208 horsepower with the electric motor. The outcome was a significant enhancement in acceleration, a quieter ride, and hybrid fuel economy approaching 50 mpg, surpassing competitors like the Honda Accord Hybrid and Hyundai Sonata Hybrid. Following this, the RAV4 also received the 8-5A engine in both its standard and hybrid configurations. For a compact SUV, this engine provided the RAV4 with remarkable performance. Its hybrid version swiftly became the top-selling hybrid SUV in North America, owing to its fuel efficiency of over 40 mpg and spirited driving feel. The success of the RAV4 hybrid demonstrated Toyota's ability to scale this new engine technology across its lineup while preserving its reputation for practicality and dependability. In larger vehicles like the Highlander, the same 2.5-liter dynamic force engine now powers the hybrid models, supplanting the older V6 hybrid systems. Despite having a smaller engine, the new configuration produces 243 total system horsepower and achieves up to 36 mpg, combined a massive improvement in fuel efficiency while also complying with strict emissions standards in both the US and Europe. After proving its mettle in midsize cars and SUVs, Toyota started deploying dynamic force engines in its smaller vehicles as well. Toyota's dynamic force engine is more than just a technological advancement. It's a declaration, a reminder that the internal combustion engine is far from obsolete. And Toyota is not prepared to surrender its leadership position without a fight. As competitors race towards complete electrification, Toyota is methodically crafting something far more strategic and calculated. But in an automotive industry undergoing rapid transformation, will this audacious engine be celebrated as a brilliant strategic move or lamented as a missed opportunity? Let us know your thoughts in the comments below, and don't forget to like and subscribe.